5, right? So that means we can take a 5 out of the radical, and what stays under the radical? The 3, right? There's a pair of 5, but there's a lone 3 that cannot be paired, so it stays under the radical. Now, when we're taking the square root of variables, it's pretty easy, right? They're exponents, we just divide by what? 2. It's because we're taking them out in pairs of 2. So we can take their exponent, divide by 2, that'll give us c to the 6th, right? What is the problem that arises when we get to d to the 5th? Right, it's not divisible by 2, so let's make it divisible by 2. Let's subtract 1 and make that a 4. Well, that 1d that you subtracted, he has to stay under the radical because he doesn't have a pair. He's the odd guy. He is the 5th wheel, okay? And he has to stay under the radical. So now we take 4 and we divide it by 2 to get d squared. And then what about the 9? What happens here? We'll make that an 8. E here, and then e to the 4th. That's getting a little squunched, but are there any questions there on number 4? Do we remember how to do this? Please let me know if you guys have any questions, 1 through 4. Okay, what about 5 through 7? Yeah, I'll do 7. I think it looks a little uglier. Did you say 6 or 7? Okay. On 7, they're wanting us to add these radicals, but we can only add radicals if they have the same number under the radical, right? And right now they don't. What we can do, though, any ideas on how we can find out if we can add these radicals? Simplify, absolutely. Let's simplify them. Can you think of some factors of 40, or the greatest perfect square that's a factor of 40? 4, right? So that's 4 and 10. And we can just take the square root of 4 to give us what? 2. But what was already out front? 2. And that's something that I notice is a mistake that students often make, is they forget about the number out front. Yes, we brought a 2 out, but there was already a 2 there. And then what does that leave us under the radical? 10. Very good. Okay, so what's the greatest perfect square that's a factor of 20? 4 and? Good. And what was out front already? 6. And then we brought out a 2, and that leaves us with a 5 under the radical. Greatest perfect square that's a factor of 45? 9, and that would be 9 times 5. Square root of 9 is, and then that leaves us with a 5 under the radical. Is this all coming back to you now? I'm just simplifying this. Now, can I combine any like terms here?
Yes.
Right, so, right, the 12 square roots of 5 minus 3 square roots of 5. And what is 12 square roots of 5 minus 3 square roots of 5? 9 square roots of 5. Very good. When we add and subtract radicals, the radical stays the same. We just add and subtract the coefficients. Kind of like we do with variables, like 3x plus 4x is 7x. So we added the coefficients, but the variables stayed the same. Here we're adding the numbers out front, but the numbers under the radical stay the same. And that would be our answer to number 7. Are there any questions? Number 7. All right. Okay, any questions on 8 through 11? My hint on 8 is I think it's easier for you to go ahead and multiply before you try to simplify. If you do not multiply before you simplify, then you could simplify, multiply, and then have to simplify all over again, which is never fun. But it's completely up to you. On number 11, you need to distribute each term in the first parentheses to each term in the second. And remember, when we multiply radicals, we multiply the numbers inside with the numbers inside, and then the numbers outside with the numbers outside. So 2 square roots of 8 times 3 square roots of 2 would actually be 6 square roots of 16. And then 2 square roots of 8 times 4 square roots of 3 would end up being 8 square roots of 24. And then I'm not going to finish the problem because I want you guys to do this, but you would then distribute 5 square roots of 3 to both 3 square roots of 2 and 4 square roots of 3. Any questions on 8 through 11? Yes, ma'am. Yeah. No, go ahead. Because, I mean, I'm sure somebody else will probably have a question as well.
So if, like, say if you multiply, like, the first one right after,
Okay.
so
Mm-hmm.
10 square root 30?
Yes.
Okay.
And then you would try to break it up, and then you realized you couldn't break it up, and then you were like, oh my gosh, I must have done something wrong. No, it's fine. It ends up being 10 square roots of 30, and you're right, you can't simplify that. And you might not even be able to combine it with anything else in that problem. So don't let that confuse you either. All right. Are there any questions on 8 through 11? Okay. All right, are we allowed to have radicals in the denominator? No. So how could we get rid of that square roots of 6 that's in the denominator? Okay, well, let's try that. Let's see what happens. He said, Harrison said that we need to multiply both the numerator and the denominator by the denominator. And that ends up giving us 4 square roots of 6 over the square root of 36. But what's the square root of 36? 6, okay? And we knew that. That's why we multiplied by the square root of 6. Now, can I simplify these two 6's here? No, why not? Right, one's the square root of 6 and the other one is 6. And if you think there's no difference, then I will take $6 million and you can just have the square root of $6 million and we will call it a deal. Not the same amount of money, right? Whole lot less. Square root of 6 million than 6 million? Yeah. So let's look at this 4 and this 6. Can we simplify those two? Yes, because they are both outside of the radical, correct? And that becomes 2 square roots of 6 divided by 3. Any questions on number 12? Okay, I'm not going to do 13, but I will let you know that the square root of 4/5 is the same as just the square root of 4 over the square root of 5. Very good. And then you can simplify from here. On 14, what's the first thing you want to do? To make this problem way easier than it looks right now? We can always start by... Okay, we could, but this might be even easier. Can we go ahead and simplify now? Right, and if we did, what is that going to give us? 25. Right? 25x squared. Do you see? That's fine. No. Do you see the 50 divided by the 2 would give us 25, right? And then remember when we divide variables, we subtract their exponents. So that would just be x squared. And the top, so that's 25x squared. And then we would just take the square root of that to get our answer. All right. Factoring, the greatest common factor. What's the GCF of 27x cubed and 18x to the 4th? 9x to the 3rd. Good. 9x cubed. So we're just dividing each term by the GCF, which is 9x cubed. And that's going to give us 3 plus 2x. Is that correct? That was pretty simple. Any questions? Now grouping. Grouping is honestly us just doing the GCF like 3 times, okay? So what's the GCF of y squared plus 4y? Y. And when we divide by y, what are we left with? Y plus 4, okay? So we just use the greatest common factor 1 time. We have to do it 2 more and then that's it. So grouping is just repeating the GCF. What is the GCF between a negative 5y and negative 20? Negative 5. Very good. So we factor out our GCF yet again. And that leaves us with y plus 4. Okay, so we've already done the GCF 2 times, and we're going to use this GCF method one more time, then we're done. What is the greatest common factor between 4y times y plus 4 and negative 5 times y plus 4? Or what's the greatest common factor between the green and the blue? Y plus 4. Good. So if we factor out a y plus 4, then we're left with what? Y minus 5. And those are our two factors. Any questions? Okay. All right, difference of squares. This is like the one that we love the absolute most because it's so, I don't like to use the word easy, but it's the least complicated method of all factoring. Would you agree? Right. So what's the square root of, we end up with two binomials, right? And what's the square root of